Graph general rational functions, 8.3. The x-intercepts of the graph of f up here are the real zeros of the numerator, p of x. Zeros are any time that the numerator, you can make it a zero. Okay. On 2, the graph of f has a vertical asymptote at each real zero of q of x. So we need to set the denominator then to equal 0 and figure out what those zeros are. And then each time we have a 0, we can get a vertical asymptote. The graph of f has at most one horizontal asymptote determined by the degrees m and n. So if m, on the top, the highest coefficient, is less than n, then we have the line y equals 0 as a horizontal asymptote. If m equals n, then we have y equals a over b, this fraction, as a horizontal asymptote. And then if m is greater than n, the graph has no horizontal asymptote. So we can have all the vertical asymptotes we want, but you can only have one horizontal asymptote in these graphs. Or you can have none. So let's look at an example. Graph this. Okay, what can we put in the numerator to make it 0? Well, we can't. There's no variables up there. So there is no zeros. So that means there's no x-intercept. You'll never cross the x line. The denominator has no real zeros. Okay, how do we know that? So x squared plus 2 equals 0. Let's set it to equal 0. Subtract 2 from each side, so we have x squared equals negative 2. Now we have a problem, don't we? When we try to take the square root of that to solve for x, we get an imaginary number. It has to be a real number. So there is no real zeros, and that means there are no vertical asymptotes. S-Y-M. I'm going to abbreviate. The degree of the numerator. Okay, what's the degree up there on the x? Well, we don't have one. So it must be a 0 because x to the 0 is 1. And is less than the degree of the denominator. The degree in the denominator is 2. So the line y equals 0. The x-axis is a horizontal asymptote. Okay, so let's try to go ahead and graph this. Let's make our xy box. Okay, if we put 0 in for x, what do we get out? 3 over 0 plus 2 is 3 halves. If we put a positive 1 in for x, we get 3 over 1 plus 2, or 3, that also is 1. If we put a negative 1 in there, negative 1 squared is positive 1, so I get a positive 1 out. And let's do one more. How about a positive 2? So 3 over 4 plus 2 is 6, so that'd be 1/2. Okay, let's graph these. So 0 and 3/2, a little over 1. 1 and 1. Negative 1 and 1. 2 and 1/2. Do you see it coming down? Now, remember that we said there's no x-intercept up here. So we're not going to cross the x line. It's going to be an asymptote. And we're just going to make it mirror image like that because there are no vertical asymptotes either. So what's the domain on here? What number can we put in for x? We can put in any real number, can't we? All positive, or positives, negatives, 0. So all reals. Okay. How about the domain for y? Now, notice that this point up here is the highest the y ever got. So that's where the y is going to go the highest. And then where does it go the lowest? Well, these are the asymptotes, right? So 0 is going to be on the low side, but it can't touch the 0. So we're going to write it as 0 is smaller than, but not equal to, just smaller than y, which is also smaller than or equal to 1.5, 1.5. And it looks like a 6, but it's really 5. So that's how you graph these. Okay, checkpoint. Graph the function. State the domain and the range. Well, this one is almost like the one before. We have a whole number on top with no variable, and so we are not going to get any x-intercept. On bottom, do we have any real zeros? No, because when we try to solve it, we'll get the -4, and then when we try to take a square root of it, it'll be imaginary. So it's going to make another kind of like a small hill looking graph. All we have to do now is do our XY table. Let's pick some points. Okay, how about 0? So put 0 in, 12 divided by 4 is 3. If you put in, let me try to get a good number. 2 in for x. That would be 12 divided by 2 squared is 4, plus 4 is 8. So 12 over 8 is 3/2. Okay, if I put a -2 in there, I'll get the mirror image 3/2. And from this, we could probably go ahead and see where it is. So 0, 3 is right here. And then 2 and 3/2. So that would be 1.5. And then over here, -2 and 1.5. We can go ahead and draw in our little hill. Alright, so we have no asymptotes that are vertical. The x line, the x equals 0, is our horizontal asymptote. And what's our domain and range? Domain, again, I can put in any x I want, so domain is all reals. And in the range, okay, what's the highest it can be? Highest it can be is 3 from this point. So, and then it can get really close to 0, but it can't touch it. So that would be my domain. Okay, we're going to graph this one. So now we look at the numerator and we find the zeros. So let's go ahead and set that up. X squared minus 9 equals 0. Add 9 to both sides, so x squared equals 9. If we take square root, remember, what do I do when I take square root? Remember, I have to take the positive and negative of it. So x can be either plus or minus 3. So positive 3, negative 3. And so they're both the, okay, that's what they want to put, plus and minus 3. So plus 3, minus 3 are the x-intercepts. Let's go ahead and go down the graph and put a point there. So here's the x line, plus 3. We're going to make a point. Minus 3, we're going to make a point. So it's going to go curve through those points during the graph. Okay, the denominator, x squared minus 4. So let's set that to be 0. Add 4 to both sides, take the square root. So it's plus or minus 2. So x equals plus 2 and x equals minus 2 are vertical asymptotes. So let's draw those lines in. Plus 2 and minus 2. So the graph cannot touch those lines, or can't cross or touch those lines. Now, do we have a horizontal asymptote? The numerator and the denominator have the same degree. They're both 2's up here. So if they have the same degree, then we're going to put the fraction, and what's the coefficient of the top one? It's 1. What's the coefficient of the bottom one? 1. 1 over 1. So the line y equals 1 is a asymptote. Not y, x, yeah, y equals 1. I'm sorry. It's an asymptote. There we go. The graph's going to look kind of weird. It can't cross the boundaries here. Now, we need to pick a lot of points to figure out what's going on here. So, pick some points to the left of the asymptote. So, if I put in a negative 5 for x, and I would probably go ahead and do this on my calculator, get a 0.8 out. If I put in negative 3 for x, I get a 0 out. If I put in a negative 1, I get 2.7. If I put in a 0, I get 2.3. If I put in a 1, I get a 2.7. If I put in a 3, I get a 0. And then if I put in a 5, I am going to get a 0.8. And like I said, I would do these on my calculator just because they're kind of long. Now, notice that they gave me 3 patterns to pick on. I need to make sure I've covered each area. So I covered this area, I've covered this area, and I've covered this area to figure out what the graph will do in all 3 points. Okay, let me go ahead and get rid of this so we can see it again. And I'm going to graph those points. Okay, it's going to go up here, almost touching the asymptote. Down here, almost touching this one. And then we're going to get a nice curve right here, like this, almost touching those, never crossing. And then I'm going to get another one over here. Oh, I don't know why it draws lines for me sometimes. So that line is not there. Let me go ahead and take it off. Try this again so you can see it a little better. So right here, right there, and right like that. A little bit neater, but that's the shape you're going to get. Strange shape, isn't it? Okay, example 3, another rational function to graph. Okay, let's factor out the numerator. So this is a quadratic. So I can go ahead and put my 2 parentheses and say, that's hardly big enough for me to write in. So let me put it up here, x minus 3 times x plus 1. And then if you can check that with the FOIL method, and sure enough, that'll equal, when you multiply it back, it'll equal this. So the x-intercepts are positive 3 and negative 1. So I'm going to go ahead and put that in my graph. Notice that, again, this is a 2 scale on my graph, so be careful. And crossing the x line at 3, right here in the middle, and negative 1 right here. Alright, the zeros of the denominator, x plus 2, what's the only number I can put in there to make that a 0? Negative 2. So the vertical asymptote is at negative 2. Right here. So my graph cannot cross that line. So x equals negative 2. The degree of the numerator is 2, is greater than the degree of the denominator, which is 1. So the graph has no horizontal asymptote. The graph has the same end behavior as the graph, x, and then you can say 2 minus 1. We're just going to subtract these 2 degrees here. And then, so what's 2 minus 1 is 1, so that's just x first. So what does the end behavior do? Well, that means that it ends like a linear equation, right? Y equals x. Remember how those end going up this way and going down this way forever. So we need to plot the points though, because this is another odd graph. So again, I would put this on my calculator, being really careful to put my parentheses and everything. And I would come up with these points: negative 12, negative 11.3, negative 10.5, negative 12, 0, move it up a little bit, negative 1.5, and negative 0.8. Okay, when I start graphing these points, you are going to see that the graph goes like this. So x-intercept here, remember this is asymptote, so I'm not going to touch that line. It's going to come down here, and then it's going to go up and shoot off. Down here, it's going to be at negative 2. So I'm going to have to, let's see, what's that, negative 2, 4. Negative 4, I'm just graphing this point right here. So negative 4, negative 10.5, so 2, 4, 6, 8, 10, and a little bit more right there. And then negative 3, negative 12, negative 2, negative 3, negative 12. It's going to go right about right there. So we get the graph this way, and then it's going to go this way. Okay, so really strange graph. And we are not even going to talk about the domain and range of that thing. So leave it alone. Okay, checkpoint. Graph the function. Okay, what are the zeros of the numerator for this? Well, it's 0 itself. So it's not going to cross, since there's only one Well, it actually is. It'll touch or cross right there. We don't know which one. Okay, where are the zeros of the bottom? X squared minus 16 equals 0. Add 16, take square root, so we get plus or minus 4. So we're going to draw these in. At plus or minus 4, again being careful of your scale. Okay, do we have a horizontal asymptote? Okay, 2 and 2, so they're the same degree. So the horizontal asymptote is going to be the fraction of the coefficients. So the fraction is 3 over 1 down here, so it will be at 3. Right in the middle here. Okay, do you see this pattern? So this is another 3-part kind of graph. So I would pick points here, and after you pick points, you will see that it goes like this, and then it comes up here, and it goes like this, and then over here it goes like this. Okay, weird, but again, it's not that hard. All right, on 3, we need to go ahead and factor that top out. So x negative 8 is plus 4, x minus 2, and then when I FOIL it, that will give me my 2x here. And then, so my intercepts are negative 4 and positive 2. 1, 2, 3, 4, negative 4, positive 2. What's my vertical asymptote on the bottom? What's the only number that can make it 0 on the bottom? Is 1. And remember why that's an asymptote? Because I cannot divide by a 0. So that's why the graph can never touch that line. Okay. And then we have 2 minus 1. Well, remember what happened when m is greater than n? Then there's no horizontal asymptote. So I can't draw any line in here. The graph won't touch horizontally. Okay. So now from here, all I have to do is pick points. Again, I would set that up on my calculator, and I get something like this. That. Okay. Without that line, this line is not here. So it's kind of a 2-part graph that curves off. These are really strange graphs. You do need to have an idea of what it will graph like before you start this, because if you mess up and don't put enough parentheses in your calculator or something, you need to know when your calculator is giving you a wrong answer.